This video is going to be part 2 of lesson 1.4. In part 1, we derived formula 1 and then applied formula 1. In this video, we're going to derive formula 2 and then use 3 examples where we will apply that formula. How we're going to start is the exact same way. So we're given a curve and we're going to be asked to find the slope at a particular point on that curve. So let's call this point P, and let's label that point. So just like with formula 1, it would be a comma, the y value here would be f of a. So what would be asked is we'd be given the formula of this curve, and then we'd be given this point, and we're told what is the slope at this point. So what I'm going to draw is I'm going to put my tangent line in. Okay. We know from Formula 1 and from Lesson 1 that I could only get the slope of this tangent line if I have 2 points, but I only have 1 point on the curve. So what we do, or 1 point on my line, I should say. So what we do is we're going to introduce a second point. And the second point, we introduce it, it's always going to be on the curve, and we're going to call that point Q. If I connect or join point Q and P with a line, what I've introduced here is what's called the secant line. And I'm able to calculate the slope of the secant line because I've got 2 different points. What's going to be different from Formula 1 is going to be the labeling of point Q. So in Formula 1, we said that this was x, and then the y value would have been f of x. What's going to happen with Formula 2 and where it changes is instead of telling us that this is x, what they're going to say is they're going to say that the distance from A to that point is h. So we're given a distance. So let's say, for example, that I said, well, how could we express the point on the x-axis here if the distance from here to here is 5? Well, this point would be a plus 5. So without having a number, what that point would be, it would be a plus h. Okay, so the x coordinate on Q is going to be a plus h. The y coordinate then on Q would be f of a plus h. What I have right now, because I've got 2 points on the curve, on the secant line, is I could calculate the slope of this secant line. So the slope of the secant line is going to be the slope of PQ, and that's going to be equal to y2 minus y1 over x2 minus x1. And plugging in the points, remember that point Q is going to be our second point introduced. This is our first point. So it's going to be y2 minus y1. So f of a plus h minus f of a. All over x2 minus x1. So it's going to be a plus h minus a. And if you look at that denominator, a plus h minus a, we could actually cancel because a minus a would cancel, and we'd be left with the slope of the secant line, which would be given by f of a plus h minus f of a all over h. Okay, so how do we use the slope of the secant line to get the slope of the tangent line? Remember that the goal is the exact same. So the goal is taking point Q, and we want to bring it closer and closer to point P. If I could get Q closer and closer to point P, the slope of the secant will become the slope of the tangent. So what we're going to write is we're going to say to find slope of the tangent, what we want to happen is we want to bring Q closer and closer to P. In Formula 1, we said we want X to get closer and closer to A, but what's actually going to happen with Formula 2 is we're going to want H to get closer and closer to 0, because, or H to approach 0, because if H is 0, right, the smaller h gets, the closer I get to this value here. So we want q to approach p, which is going to be the same thing as h approaching 0. And if that happens, then the slope of the secant is going to approach the slope of the tangent. And our equation of the tangent line is going to become the limit as h approaches 0. So instead of x approaching a, we're going to have h approaching 0 of f of a plus h minus f of a all over h. This is what is Formula 2. This is what Formula 2 will look like. It's going to be more involved than Formula 1, but in university, you'll almost exclusively use Formula 2. What we're going to do is we're going to look at this example here, and this example was the identical example that we did in part 1. So if you look at class example 1 for Formula 1, it was this example here. We're going to use Formula 2 now, and what you're going to see is that we're going to get the exact same value that we did using Formula 1. Okay, so what's happening? We are given a curve, which is going to be a parabola, and we're asked to find the slope of the tangent at that point on the curve. So if I take that point, remember that that, just like Formula 1, is your A value, and this is your P of A. Sorry, F of A. So F of A is equal to 6, or F of 2 is equal to 6. If you plug 2 into the function given, 2 squared is 4 plus 2 is 6. I just want to double check that I did write F of A, not P of A. Yes, okay. Okay, so the slope of the tangent is given by the limit as h approaches 0 of f of a plus h minus the f of a all over h. What we're going to do from here is we know what the value of a is. So the value of a is 2. So I'm going to rewrite this, substituting in 2 for a. So I could say that the limit as h approaches 0 of the f of 2 plus h minus f of 2 all over h. Okay, here's where it gets to be more work than Formula 1. Because what has to happen is they're telling me into my function, input 2 plus h whenever you see an x. So this was my given function here, and whenever I see an x, I need to input 2 plus h. So what that would look like, and I need to start it out with the limit. Actually, I'm going to just go down. So that would be equal to the limit as h approaches 0 of, it's going to be 2 plus h squared plus 2 plus h. Then that is minus f of 2, and f of 2 was 6, all over h. From here, we've got two binomials, or binomials squared. So I'm going to write that binomial twice, and we're going to expand it. So the limit as h approaches 0 of 2 plus h, 2 plus h. There's an invisible 1 here, so I could get rid of that bracket. Plus 2 plus 1h minus 6 all over h. Let's expand using the distributive property. So the limit as h approaches 0, that will be 2 times 2 is 4, and then I would get plus 2h plus 2h, so I'm just going to write plus 4h plus h squared. Over here, I'm going to combine 2 minus 6 to be minus 4, and then bring down that plus 1h all over h. Remember that if we substituted in h, we'd have an indeterminate. So we want to get rid of that by algebraically being able to cancel something because I can't put h is 0 here. So if you look at the numerator now, what can we clean up? So I've got 4 minus 4 will cancel, and I'm actually going to combine my like terms. So 4h and 1h would give me 5h. So this is going to be the limit as h approaches 0 of 5h plus h squared all over h. Let's factor out an h from the numerator. And we would have 5 plus h all over h. And then here's where our factors will cancel. So that cleaned up to be the limit as h approaches 0, 5 plus h. And now I could substitute in. I no longer need to write limit. So that's going to be 5 plus 0, and that is equal to 5. What we just calculated is the slope of the tangent line to be 5. So on the curve, which was a parabola, at the given point, the tangent line would have a slope of 5, is what we've just calculated. And again, look back to class example 1, and using formula 1, we got the slope of the tangent being 5 as well. Let's look at another example, same type of thing where we're going to apply, we're going to find the slope of the tangent to the curve using formula 2. So first of all, I don't even know what my curve is. I need to get the equation of my curve. So I'm going to divide x and divide x. And the curve is going to be y is equal to negative 6 over x. So it's going to be irrational. From here, I know that 2 is my a value, negative 3 is my f of a. So again, f of 2 is equal to negative 3. The slope of the tangent is given by the limit as h approaches 0 of f of a plus h minus f of a all over h. That's equal to the limit as h approaches 0 of. Now remember for this, what I'm going to do is a, I know what the value of a is. A is 2. So I'm going to rewrite this again, and I'm going to just input 2 for a. So f of 2 plus h minus f of 2 all over h. Once you get to this step, we could now take this 2 plus h and input that into my given function. So if I look up here, here's my given function. Whenever you see an x, so right here, you're going to input 2 plus h. So we're going to have rationals. So I'm going to have negative 6 over x. X comes out, and 2 plus h goes in, minus the f of 2 is negative 3. And then that is all over h. So a couple of things. Let's get rid of these two negatives. So 2 negatives will give me a positive. So let's clean that up. And then let's get common denominators so that I could combine these two fractions. So if I've got 2 plus h in the denominator for that first fraction, I'm going to multiply this by 2 plus h and the numerator by 2 plus h. I would have negative 6, and I'm going to distribute in this 3. So plus 6 plus 3h over 2 plus h. And remember, that was all over h. So this was the denominator, and I'm going to turn that into a fraction by putting it over 1, because eventually what I'm going to do is I'm going to write this fraction, and instead of dividing it, I'm going to rewrite this first fraction and multiply it by the reciprocal of this. But let's clean up a couple of things from that first fraction. So the limit as h approaches 0, negative 6 and 6 will cancel. So I'm going to be left with 3h over 2 plus h. And again, instead of dividing by h over 1, I'm going to multiply by the reciprocal, 1 over h. At this stage, h and h would cancel, and what I'd be left with is the limit as h approaches 0 of 3 over 2 plus h. And then again, let's input, at this stage I could input h to be 0, so 3 over 2 plus 0 is equal to 3 over 2. And on my given curve, the point that I was given, the slope at that point, which would be my tangent line, would be 3 over 2. So that would be the slope of my tangent. Okay, so 2 examples now where we've seen Formula 2 being applied. Something different is going to happen with this third and last example. And it starts off the same way. Determine the slope of the tangent line at this curve. So again, we're given another parabola, but they don't actually give me the point on the parabola, right? So what they say is they say that they just say at x is equal to a. So we always know that this is going to be the point on the curve, and we're going to find the tangent at that point. So I don't know what it is, though. They're just saying at some value for a, and then that would be f of a. So they haven't told me what point on the curve they want. They just said at point A. So let's see what we could do with this and then what that will mean. The slope of the tangent is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. Normally what we did from here is we knew what our a value was, right? I knew the point given on the curve, what the x coordinate was, and we substituted in. I don't know what it is, so I can't take a out and substitute. So right from here, I could now, into my given formula, my given function, I'm going to input a plus h, right? So wherever I see an x, just like before, I'm going to input a plus h. So this is going to be the limit as h approaches 0. So the f of a plus h would be a plus h squared minus 1 minus the f of a. So what was the function? This was our function. So the f of a is our given function, and that would be x squared minus 1. Sorry, a squared minus 1. Right? So into our function, it just says to input an a into the function, which would be a squared minus 1. And that's all going to be over h. This is going to be the limit as h approaches 0 of, I'm going to write that binomial twice. So a plus h minus 1. And then I'm going to distribute this in. Minus a squared plus 1. That's all over h. That is equal to the limit as h approaches 0. Let's use the distributive property to get rid of those brackets. So it's going to be a squared plus ah. So I'll say plus 2ah plus h squared. Bring down that minus 1 minus a squared plus 1. That's all over h. Okay, what can we clean up from here? So we have an a squared minus an a squared. I've got a negative 1 and I've got a positive 1. I'm left with this, and I'm going to rewrite it as the limit is equal to as h approaches 0, but I'm going to factor out an h from the numerator, just so I could save myself a step. So this is going to be equal to the limit as h approaches 0. So again, this is all that I'm left with. So let's factor out an h, and we'll get 2a plus h over h. That will allow us to cancel our h's, and we will no longer have an indeterminate answer. So we will be left with the limit as h approaches 0 of 2a plus h. Now I'm going to substitute in 0 for h, so that's going to be 2a plus 0, which is equal to 2a. So we're going to talk about what we just solved. Remember that this is always the slope of your tangent. So the slope of my tangent is equal to 2a. What that means and why this is like powerful that we know this is now I could give you any point on that curve and you could substitute that point in for a. So I could say when x is 5, the x value on that curve at 5, what would the slope be? 2 times 5, the slope would be 10. So I could give you any x values and say what would the slope of the tangent be at those particular points. There's two questions in the work, um, in your homework that practice this, and it's going to be questions 9 and 10, where you're not going to be given the x value, so you're just going to be told x is equal to a, and you'll be given solving an expression so that we could solve any point on our particular curve. This was the rest of the homework, and the work solutions I will put up on the Google Classroom for you.